There is a hole in our universe, a region of emptiness so vast it's known by a single, chilling name: the Great Nothing. Welcome to the Purple Files. If you enjoy our videos, please consider subscribing to the channel. Let's get right into it. When you step outside on a clear night, far from the blinding glare of city lights, you are greeted by one of the most sublime sights available to us. A deep, velvet black canvas, dusted with thousands upon thousands of brilliant points of light. It feels infinite, packed with stars, a dense and busy cosmos stretching on forever. But this magnificent view, this feeling of looking into a crowded universe, is a beautiful illusion. Every single star you can see with your unaided eye is a local neighbor. They all belong to our home, the Milky Way galaxy. You are not looking out at the vast universe, you are simply looking around our own stellar city. To truly understand the universe, to see its true shape and character, you have to zoom out, way out, far beyond the 400 billion stars of the Milky Way, until our entire galaxy shrinks to become just another single point of light among countless others. It is only on this grandest of scales that the universe finally reveals its true structure. And it is not a random scattering of galaxies. It is an intricate and magnificent cosmic architecture, a celestial framework of unbelievable size. Scientists have a name for it: the cosmic web. Think of it as a three-dimensional spider's web of unimaginable proportions. The long, bright, shimmering threads of this web are made of enormous chains of galaxies, structures we call filaments. Where these filaments intersect, they form dense, massive knots of matter which we call superclusters, some containing thousands of individual galaxies, all bound together by the relentless pull of gravity. This cosmic web is the very backbone of the universe, the structure upon which everything is built. But any web, any structure at all, is defined as much by the empty spaces between the threads as by the threads themselves. In the cosmos, these vast, dark, empty regions are called voids. They are a natural and expected part of the universal structure, the dark oceans that separate the bright continents of the superclusters. But what if astronomers found a region of emptiness so vast, so profound, so utterly desolate that it defied all expectations? What if they found a hole in the fabric of the cosmos so large that, according to our best theories, it simply should not exist? This is the story of a place that has earned the most fitting and chilling nickname in all of astronomy: the Great Nothing. Our story begins not with a grand and dedicated search for cosmic emptiness, but with a patient, methodical, and what was thought to be a routine scientific survey in the year 1981. A team of astronomers, Robert Kirshner, Augustus Oemler Jr., Paul Schechter, and Stephen Schechtman, were engaged in the painstaking work of mapping a small patch of the universe. They were conducting what is known as a redshift survey, a cornerstone technique for charting the cosmos in 3 dimensions. The principle behind it is one of the most fundamental and powerful tools in all of cosmology. As the universe expands, it stretches the very fabric of space-time, and in doing so, it also stretches the light that travels through it. Light from distant galaxies is stretched to longer, redder wavelengths in a process called redshift. The farther away a galaxy is, the more its light has been stretched and the greater its redshift. By carefully measuring this redshift, you can calculate a galaxy's distance from us. By repeating this process for hundreds of galaxies in a single direction, you can build a 3-dimensional map, revealing the cosmic structure layer by layer, like an archaeologist excavating a forgotten city. Their telescopes at the Kitt Peak National Observatory were pointed towards a region of the sky in the direction of the northern constellation Boötes, known as the Herdsman. They expected to find what decades of observation had taught them they should find: a steady, fairly regular distribution of galaxies, one after another, stretching back into the cosmic distance. They began their meticulous work, pointing their telescope at a faint smudge of light, carefully measuring its redshift, calculating its distance, and then moving on to the next target. But soon, a strange and deeply unsettling pattern began to emerge from their data. After finding a handful of galaxies at a certain distance, they suddenly found nothing. They would aim the telescope at a spot where a galaxy should be and see only an abyss. They would search deeper, far beyond the first few galaxies, expecting to find the next layer of the cosmic web, but there was nothing there. The team's first reaction was not excitement, but professional doubt. This result was so bizarre, so contrary to all previous models that it had to be an error. Perhaps their sensitive equipment was malfunctioning. Perhaps there was a subtle flaw in their calculations that they had overlooked. They checked everything. They recalibrated their instruments. They repointed the telescope to a different spot within the same celestial region and began the entire process again. And again, the same impossible result came back. Nothing. A vast, silent, empty hole seemed to be staring back at them from the data. It was a profound discovery made not by observing something new and brilliant, but by observing a profound absence of things on a scale that was, at the time, utterly incomprehensible. They slowly came to the realization that they were not just looking at the normal, expected space between galaxies. They had stumbled upon the edge of a void so large it would force a complete re-evaluation of how the universe was built. They had found the great nothing. So, just how big is this hole in the heavens? The numbers involved are so colossal that they are difficult for the human mind to truly grasp, but we must try to put them into perspective to understand the significance of this discovery. The Boötes Void is estimated to be roughly spherical in shape, with a diameter of nearly 330 million light-years. A light-year, the distance light travels in a single year, is already a mind-boggling distance of nearly 6 trillion miles. This void is 330 million times larger than that. Let's try to place that staggering figure into a more relatable context. Our own Milky Way galaxy, a sprawling city of up to 400 billion stars, and a home we think of as unimaginably vast, is about 100,000 light-years across. This means you could line up 3,300 Milky Way galaxies end to end just to span the diameter of the Boötes Void. Imagine another way. If you were to shrink our entire Milky Way galaxy down to the size of a small marble, the Boötes Void would be a colossal, empty sphere nearly 50 meters, or more than 160 feet, across. It would be an empty ball half the length of a football field, and our entire galaxy would be just a tiny marble lost inside of it. Here is perhaps the most profound way to visualize the scale. Imagine you could board a spaceship that travels at the speed of light, the absolute unbreakable speed limit of our universe. Even at this ultimate velocity, it would still take you 330 million years to fly from one side of the void to the other. A journey so long, it makes the entire 200,000-year history of our species, Homo sapiens, seem like a fleeting instant. The dinosaurs would have been extinct for 65 million years when you were only a fifth of the way across. The entire story of humanity would unfold and end long before your journey was even halfway complete. Now, the name The Great Nothing is a powerful nickname, but it is a slight exaggeration. It is not that there is absolutely nothing there. The issue is what should be there. Based on the average density of matter we see elsewhere in the universe, a region of space this large should contain many thousands, perhaps even tens of thousands, of individual galaxies. The painstaking surveys conducted in the decades since its discovery have so far found only about 60 lonely galaxies adrift in a sea of emptiness that should hold thousands upon thousands more. It is the cosmic equivalent of surveying the entire continent of North America and finding nothing but a few dozen small, isolated villages with no towns, no cities, no states, and no highways in between. It is this staggering disparity between what should be there and what actually is there that makes the Boötes Void one of the most astonishing and important structures ever discovered. The existence of the Boötes Void is so shocking because it appears to challenge the very rules of how the universe is supposed to assemble itself over billions of years. According to our best and most tested theory, the standard model of cosmology, the grand structure of the universe, this cosmic web, grew from microscopic seeds that were planted in the fiery moments immediately following the Big Bang. In its infancy, just fractions of a second after its creation, the universe was an incredibly hot, dense soup of particles and energy. Crucially for our story, this primordial soup was not perfectly uniform. There were tiny, random quantum fluctuations, creating areas that were infinitesimally denser than their surroundings. For the next 13.8 billion years, the relentless and patient force of gravity has worked on these tiny initial differences. The regions of the early universe that started out slightly denser, containing just a little more matter and more of the invisible scaffolding we call dark matter, exerted a slightly stronger gravitational pull. Over eons, they pulled in more and more material from their surroundings, growing steadily over cosmic time. These became the long, bright filaments and the massive, dense superclusters of galaxies that make up the cosmic web we see today. Conversely, the regions that started out slightly less dense lost the cosmic tug of war. Their matter was pulled away from them, flowing like cosmic rivers towards the growing filaments and clusters. These less dense regions therefore became emptier and emptier, expanding to become the voids. Think of it like baking a loaf of bread. As the dough rises, the yeast creates bubbles. The bread itself forms a connected, sponge-like structure, and the bubbles are the empty voids within it. Our cosmological models are excellent at predicting the average size of these bubbles. They should be big, but the Boötes Void is an outlier of the most extreme kind. It is a statistical anomaly. It is significantly larger than what our standard models of cosmic evolution can comfortably create in the 13.8 billion years the universe has had to work with. A void of this magnitude is an incredibly rare event, so rare that its very existence forces us to ask a very difficult and fundamental question. Is our understanding of the universe's evolution missing a crucial piece of the puzzle? So if the standard model of our universe struggles to explain it, how could such a monstrous void have possibly formed? How do you create a region of such profound emptiness? The leading and most widely accepted scientific explanation is that the Boötes Void is not a single monolithic entity that was born this way, but is instead a composite structure, formed from the merger of smaller voids. The theory suggests that the universe in this particular region originally formed with a collection of smaller, more normal-sized voids, the kind our cosmological models have no problem predicting. Over the immense timescale of billions of years, these smaller voids began to drift through space and interact with one another, much like soap bubbles floating in a sink. When two soap bubbles touch, their thin walls merge and they coalesce to form a single, larger bubble. It is believed the voids did the very same thing. As these smaller voids merged, their collective gravitational influence would have acted like a cosmic snowplow on a truly epic scale. They would have pushed the galaxies and the vast, thin clouds of intergalactic gas that were once scattered between them outwards, effectively sweeping the entire region clean. This process would have piled up the displaced matter, the galaxies, the gas, the dark matter, into the dense walls and bright filaments that we now observe surrounding the void. This elegant theory explains not only the extreme emptiness of the void itself, but also why the few galaxies on its edge seem to be packed together into a relatively thin, sheet-like structure, like cosmic debris that has been pushed to the side of a celestial road. This void merger hypothesis is the most plausible explanation we have, as it uses known physics and processes, just on a scale that is hard to witness directly. While this merger theory is the most scientifically sound, the void's sheer mind-boggling scale has led some scientists to propose more exotic, more speculative ideas. These ideas remain on the very fringes of established science, but they serve to highlight just how extreme and unusual the Boötes Void truly is. Some have wondered if such a feature could be the scar from a collision between our universe and another, a sort of cosmic bruise left over from an unimaginable event in the distant past. Others have theorized it could be evidence of exotic physics we do not yet understand, perhaps involving the behavior of dark energy on very large scales. These are not mainstream theories, but they are born from the central, difficult fact that the Boötes Void is a structure that pushes the boundaries of our imagination and tests the absolute limits of our cosmological models. Let us take a moment to move beyond the physics and the grand theories and instead consider the philosophical implications. Let us consider those 60 or so known galaxies that lie scattered like lost ships inside this great ocean of emptiness. They are, without any serious question, the loneliest galaxies in the entire known universe. Imagine for a moment that you are an astronomer on a planet orbiting a star in one of these isolated stellar cities. Perhaps the galaxy catalogued as Morphological Catalogue of Galaxies plus 01-02-015. From your home world, the night sky would be a blanket of the most profound, unending, and perfect blackness imaginable. You would see the stars of your own home galaxy, a familiar city of light surrounding you. But beyond that, there would be almost nothing. There would be no brilliant milky river of light splashed across the sky, because your galaxy is an isolated island, not part of a larger galactic plane like ours. There would be no neighboring galaxy like Andromeda, which is visible to us on Earth as a faint, hopeful smudge to the naked eye. For most of your civilization's history, you would have every scientific reason to believe that you are utterly and completely alone in the universe. Your most powerful telescopes would scan the skies for eons and see nothing but the void. The great cosmic filaments, the walls of the void containing all the other galaxies, would be hundreds of millions of light years away. Their light would be so faint, so ancient, so incredibly redshifted by its long journey that you might not even discover their existence until your civilization had developed technology far beyond anything we possess today. Think of the impact this would have on your culture, your religion, your philosophy. Humanity has always looked to the stars and felt a sense of wonder, a connection, and a feeling of being part of a vast, populated cosmos. A civilization born inside the Boötes Void would look out and see only a terrifying abyss. Their entire understanding of their place in the universe would be shaped by an overwhelming, undeniable, and scientifically proven sense of absolute and total isolation. The discovery, if it ever came, that the universe was not empty, that the darkness was in fact a local anomaly, and that beyond it lay trillions of other stars and galaxies, would be the single most transformative moment in their history. A revelation that would reshape their entire worldview. In the end, the Boötes Void is far more than just a cosmic curiosity or a spooky patch of sky to fuel our imaginations. It is a unique and invaluable natural laboratory for studying the universe. Its very emptiness, the feature that makes it so strange, is also its greatest scientific asset. It provides us with a clean, uncluttered, and direct line of sight to study the faint light from the most distant objects in the cosmos, allowing us to probe the early universe in ways that are difficult in regions crowded with foreground galaxies. The light and gas from thousands of intervening galaxies can obscure and distort our view, but the void offers a pristine window into the deep cosmos. Most importantly, however, the void serves as a crucible for our most fundamental theories. It is a stress test for our entire model of cosmology. If our understanding of gravity, of the nature of invisible dark matter, and of the mysterious dark energy that drives the universe's accelerating expansion is correct, then it must be able to account for the existence of structures like this one. The fact that our models struggle to easily produce a void of this scale tells us that our knowledge is still incomplete, that there are new discoveries yet to be made and new physics yet to be understood. This is how science progresses. It seeks out the anomalies, the things that do not fit, because they are the signposts pointing the way to a deeper understanding. The Boötes Void forces scientists to refine their models, to question their base assumptions, and to consider new possibilities about the fundamental forces that have shaped our universe over 13.8 billion years. It is a giant silent reminder that the cosmos is complex and often more extreme and more wonderful than our theories initially predict. It shows us that even in the near total absence of matter, there is a profound and compelling story to be told. The Great Nothing is not an absence of information, it is a rich source of it. By studying this vast, dark, and lonely place, we learn more about the brilliant, crowded, and interconnected universe that exists all around it. It is a window into the dark, and through it, we see more clearly just how much we still have left to discover. And that is it. If you've enjoyed this video, please consider subscribing to the Purple Files. Click the like button and drop a comment down below. More videos to come, and until then, thanks for watching.